Okay, now we'll do example number 2. A box with a square base and open top must have a volume of 32,000 centimeters cubed. Find the dimensions of the box that minimize the amount of material used. So first let's assume that B equals base length. And H equals height. So we know our volume equation, which is 32,000 equals base squared times height. And our surface area equation is S equals B squared plus 4HB. And now we can simplify this equation to get H equals 32,000 over B squared. And then we can plug this into the H and the surface area equation. So you get S equals B squared plus 4 times 32,000 over B squared times B. And then we can simplify that to get S equals B squared plus 128,000 over B. And again, we solve for the derivative because we are solving for an absolute minimum. So you get S prime equals 2B minus 128,000 over B squared. And then we're also solving for a slope of 0 because, again, it's a minimum. So 0 equals 2B minus 128,000 over B squared. And then we can solve for B. 0 equals 2B cubed minus 128,000. Bring 128,000 to the other side. And we get B equals, or B cubed equals, B equals cube root of 64,000, which equals 40. Now that we have our critical number of 40, we know that it has to be on the interval between 0 and 40 and 40 and infinity. And me just picking random values in these intervals, I'm going to pick 20 and then I'm going to pick 50. And if I plug this into our equation right here, then we get negative 112,000 as our slope, and then 122,000 in our slope. And because it's going from a negative slope to a positive slope, we know it's a minimum. And then we take our 40 value, our critical number, and then we plug it into B squared in this equation, and we get H equals 20. And those are our dimensions.